Calculate the average velocity and Reynold number in a 20-inch pipeline that transports diesel fuel at a flow rate of 250,000 barrels per day. Assuming 0.375 inch pipe wall thickness and the diesel fuel properties as follows: specific gravity as 0.85, kinematic viscosity as 5.9. What is the flow regime in this case? Now, to calculate the average velocity, the flow rate is the same thing as area times velocity. Now, your velocity will now be equal to flow rate divided by area. Now, the area, to calculate the area, before we calculate the area, we need to calculate the internal diameter. So the outside diameter is D equal to 20 inches. Then the pipe wall thickness T is equal to 0.375 inches. Now our D will be equal to the outer diameter minus 2 times the wall thickness, because let's say this is a pipe. This is the outer diameter. Which is D. This one is the inner diameter D, small d. Then here is the thickness. When you check the thickness, is to get the outer diameter is D plus this plus thickness here too, which is 2. So is D is small d plus 2d will give you this. So D will now be equal to the outer diameter minus 2t. So now you now have this as 20 inches minus 2 times 0.375 inches. Now you are left with 20 inches minus 0.750 inches. So this will give us 19.25 inches. Now to get the area now, the flow area will now be pi d square over 4. If you substitute that into this equation, let me call this equation 1, equation 2. So if you substitute, let's call this equation 3. Now if you substitute A equal to pi all over pi d square all over 4 into equation 2, you have V now equal to 4q all over pi d square. To get your V now will now be equal to 4 times Q, or Q is 250,000 barrel per day. Divide by 5 times the small d is 19.25 inches square. Now we're left with this. So we needed to change this. Now we have 4, and you know our answer is supposed to come in form of in feet per second. So we will now have to change this. You say 250,000 barrel per day times. So one barrel is equal to 42 gallon. So now you now have 42 gallon all over 1 barrel. You multiply this with that. So you also multiply this with, now you have this one will cancel out this. Okay, let me just write the units in. Let me write the units in a different column. Okay, let me leave it this way. So this barrel will cancel this one. You're left with gallon per day. Now we need to change this gallon per day too. We need to change the gallon per day too. Now you have 231 inches cube. 232 inches cube is equivalent to 1 gallon. Equivalent to 1 gallon. So now we have changed this thing to inches completely. We now have here. Now we need to change this day. The day now. So 1 day is the same thing as 24 hours. So this one will cancel out this day. So it will be inch cube per hour now. So this times this one now, to change this hour to minutes, you now have 1 hour divided by 60 minutes. Now to change the minutes to seconds, you now have 1 minute divided by 60 seconds. The whole of this divide by 5 times 19.25 inches square. So now you have all we do multiply. We use our calculator to multiply out to get our answer. So our answer should be in inches. Our answer should be in inches per second. Now let me bring up the calculator. Now I will now have 4 times 25,000 times 42 times 231 divided by this 24 divide by 16 divide by 60 divide by pi, divide by 19.25 square equal to, so we have this. So this is in inches. Let's say our answer is in inches per second. Now we need to change it to feet. So 1 feet is equivalent to 12 inches. So these inches will cancel this. So we are now left with the answer divided by 12 inches, 12, which will now give us feet per second. So now we divide that result, the whole of this we got now, by 12. So I will do that. So dividing this, which is the answer, by 12, I have, so my answer should be 8.038 feet per second. This is the average velocity. The average velocity. So now we need to calculate the Reynold number. So Reynold number is something as density times the average velocity times the internal diameter divided by viscosity. So, and you know that what they gave us kinematic viscosity, and kinematic viscosity is same thing as saying the kinematic viscosity is same thing as saying the viscosity divided by rho, which is the density of the fluid. Now, if you substitute this, let me call this equation. Let's say this is equation 4. This is equation 5. Now, if you substituting V equal to kinematic viscosity equal to viscosity divided by density into equation 4, you now have Reynold number equal to average velocity times d divided by kinematic viscosity. Now we have average velocity to be 8.038 feet per second times the diameter is 19.25 inches divided by the kinematic viscosity, which is what? The kinematic viscosity is 5.9 centi-stoke. It's what? 5.9 centi-stoke. Now you have 8.038 feet per second times 19.25 inches, so we need to change this inches to feet. So we say times 1 feet divided by 12 inches. So 1 feet is equivalent to 12 inches. So these inches will cancel out this, it will remain feet. Divide by 5.9 centistoke. Now we need to change this into feet square per second. So 1 centistoke is equal to 1.076 times 10 raised to power minus 5 feet square per second is equal to 1 centistoke. So this centistoke will cancel out the centistoke. We are left with feet square per second. So it will not be non-dimensional unit. So let's bring out our calculator. You have this. We have the velocity, which is this now, times 19.25 divide by 12 divide by 5.9 divide by this value 1.076 exponential minus 5 equal to this. So we now have we now have 203,114 as our Reynold number. So since the Reynold number is greater than 4,000, so this is a turbulent flow. So the region is, so it's a turbulent flow, so that is the region, the flow region. So that is the flow region. So that is it. Let's so what's the flow region? So the flow region is a turbulent flow. So let's end it here. Let's end the lecture here. Thanks for watching.